In this video, we're going to take a look at some of the chemical reactions that occur with alkenes. And they have some special names, and the names derive from what's happening or what's going on. So the nice thing is they're not named after people primarily. Like it's not called the Chucky reaction or the Beverly reaction. Not that we have anything against Chucky and Beverly, but if you don't know them, you don't probably care about any reactions they came up with. And so we're going to take a look at some of the chemical reactions and their names. So the first one we're going to take a look at is a hydrogenation reaction. There's a lot of syllables in that word, hydrogenation. Hydrogenation. Okay, so hydrogenation reaction. We're just going to start out here with carbon double bonded to carbon like this. Okay, and we could throw some hydrogens in there, I guess. I suppose maybe I should do that. I'll go CH2 double bonded CH2. Okay, so here is an unsaturated hydrocarbon. This is ethene. So ETHE and ethene. Okay, and I don't have to put a number in front of it because there's only one possible place for that double bond to be. Now, the hydrogenation, we're going to add some hydrogen to this. So H2, like this, H2. And what some people might find helpful in this is you can write H2 like this. There's hydrogen gas. You could also write it like this, if it helps, H-H, okay? And it's just showing that there's a single covalent bond here between those two hydrogen atoms. And we're going to break those, and we're going to break this double bond, and we're going to add a hydrogen to either one of these carbons. And so our reaction here happens, okay? And in this reaction, we might write the catalysts and such, and it'll be something really expensive like platinum, PT here like this, and 150 degrees Celsius, and some amount of pressure. Now, these catalysts, that's not terribly important, not for this class, but it just doesn't happen on its own. It takes some coaxing to make that happen. All right, so we're going to break this hydrogen molecule apart, and we're going to add it here. And so then we end up then with CH2, CH2, and we've added a hydrogen to each one of these. We've added a hydrogen to each one of these by breaking this apart. Added a hydrogen, see we broke that double bond. And we could rewrite this now, if it helps, CH3, CH3. Okay, so we've got 3 hydrogens around each one of those carbons. Now that's a hydrogenation reaction. So let's see if I can write that out, because that's a big long word there. Hydrogenation. Lots of syllables there. Okay, so going in this direction, it is hydrogenation. We're hydrogenating it. If we go in the opposite direction, it becomes dehydrogenation. So dehydrogenation. Okay, and that's going in the opposite direction. Opposite direction. Okay, now, you might have seen this before. If you take a look at something that you buy in the grocery store, it might say that it is made out of hydrogenated something or other, like hydrogenated soybean oil or dehydrogenated soybean oil. And what they're doing is they're either adding or removing hydrogen. Okay, they're just adding or removing hydrogen. And this happens a lot in food. If you take a look at food, you might see that they've hydrogenated or dehydrogenated some oils in your food. Next time you take a look at your food labels. All right, so that's hydrogenation. Now the next one we're going to take a look at is halogenation. Okay, halogenation. So halogenation is where we're going to add a halogen. So that's things like chlorine, bromine, iodine, fluorine. Those are halogens. So let's go back here to our CH2 double bond CH2, and then we're going to add a halogen here. So let's just do chlorine. So Cl2, and you could do it Cl-Cl if that works for you. And this one here just kind of happens on its own. We don't need catalyst for this one. And so what happens is we're just going to break this molecule apart, and we're going to add a chlorine to each one of those carbon atoms. And so our product here becomes CH2-CH2, and then we add a couple of chlorines on here. We can go like this and like this, chlorine and chlorine like that. Okay, now if we wanted to name this, okay, so this one here is ethene. Ethene, and now we've added a couple of chlorines here. It's still ethene, but now there's no double bond, so it becomes ethane, and we've got a couple of chlorines on there. And so this, we've got carbon number 1, carbon number 2, so this becomes 1, 2 dichloro, and then there's 2 carbons here, dichloroethane, ETH, not ethene, ethane, 1,2-dichloroethane. Okay, so that is halogenation, adding a halogen, and it doesn't matter here if it's bromine or chlorine or iodine. You get the same kind of thing over there on the end. All right, now let's see what else we got here. Hydrohalogenation. Hydrohalogenation is when we're going to be adding a halogen and a hydrogen atom to something. So we're going to go back here to our ethane. Go CH2 double bond CH2, and we're going to add hydrohalogenation. So that means we're adding here HCl, or it could be HBr, so hydrochloric acid, hydrobromic acid, or hydroiodic acid. Any one of those. Okay, any one of those. And this just kind of goes on its own. We don't need any catalyst for this one. And what we're going to do is we're going to add a hydrogen to one of these carbons, and then we'll add the halogen to the other carbon atom. So for HCl here, this becomes carbon CH2, CH2, like this, and then we'll add a hydrogen here, and we're going to add, in this case here, a chlorine, like that. Okay, like that. And if we wanted to name this, then let's see, we could go 1, 2, or 1, 2. We want to have the lowest possible number, and we've got chlorine here. So I'm going to make this number 1, this number 2, and so this becomes 1 chloro. What's that spelling thing again? It keeps getting me. CHLOR, 1 chloro ethene. Okay, 1 chloroethene. All right. And then now we're going to take a look at the next one is hydration reactions. And hydration reactions is where we add water to something. So let me get rid of this here. Let me go like this here. We're going to do a hydration reaction. Hydration reaction is where we add water. And I'm going to start out with something a little bit different here. I'm going to go CH2 double bond CH, and then CH3. 3, like this. Okay, so this one's a little bit longer here, like this. Okay, and if we wanted to name this one, this is 3 carbon atoms. There's a double bond there, so this is propene. Okay, propene. And you might think, all right, we should put a 1 there, right? Go 1 propene. But it doesn't really matter because it's got to be either here or it's got to be here, right? And so it doesn't really matter. So you just call this one propene. With this hydration reaction, we're going to add water. And some people like to go H2O when they write water, and that's fairly common. I oftentimes like to write water as this, H-O-H, okay? And the reason I do that is because we're going to break this apart, and we're going to end up with a hydrogen and a hydroxide group here. Okay, so hydrogen ion and a hydroxide ion there. All right, so that's going to give us then a product here that looks like this, and we're going to add a hydrogen and a hydroxide, right, onto this molecule. And so, for example, here we have CH2CH and CH3 like this, I think. Okay, I think. All right. And then we're going to then add a hydrogen like this, and then we're going to add a hydroxide, an OH, like that. Okay. And then we go, oh, okay, all right, good. And we pat ourselves on the back and we're feeling pretty good. But what if it did something different? What if it did this instead? What if this OH ended up over here, like that? So what if it went CH2OH, like this, and then CH, and then a hydrogen, and then CH3, like this? What if it did that? I say, is that the same molecule? No, it's not. It's not the same molecule. And so there's 2 possibilities here. This OH could go here on the first carbon, or it could go there on the second carbon. And you go, oh, okay, how do we know which one it does? Because it turns out in this reaction, we do end up with both of these products, but we end up with more of one than the other. So one is more favored than the other. And the way that we predict this, there's this smart dead guy named Markovnikov, okay? Smart dead guy, Markovnikov. And he came up with something called the Markovnikov rule. And you come up with a rule, you get to name it yourself, right? You can call it whatever you want. So he comes up with the Markovnikov rule, and it goes like this. Whenever you add hydrogen and something else to a molecule like this, and you get these 2 different options, the hydrogen likes to go where there's more hydrogen. Hydrogen likes to go where there's more hydrogen. And so as we take a look at these 2, maybe I'll go back to this one. This has got 2 hydrogens here, and there's 1 hydrogen here. And the hydrogen likes to go to the carbon that has the most hydrogen, which is going to be this one. And I know what you're thinking. You're saying, oh, wait a minute, Professor Locken, that one's got 3, right? And 3's way bigger than 2, like 50% bigger. I can count, right? Yeah, but the double bond's here. So the double bond is here, and that's what's going to break and allow the hydrogen and the hydroxide here to attach. Okay, so we're just looking at these 2 carbons here. These 2 carbons here. This one's got more, and so we're going to end up with the hydrogen attaching to this one. So this one here becomes favored. This is favored, and this one here is pukey, right? This is, according to Markovnikov's rule, we're going to end up with more of this than we end up with this.